Hi, everyone. Thanks for joining. This is an exciting call, so I'm glad to have you guys here. Today, we're going to talk about a couple of HIPs, and then somebody from our team is going to talk about our AI hackathon. Before we get started, I would like to bring up a particular thing that I would invite you guys to participate in, and that is our EVM survey and tooling survey. There's going to be some links on the screen that you can check out and participate in that survey. On top of that, we are having an AI hackathon coming in the future, and there's going to be some information on the screen as well, so you can get some information on that. And before I introduce the speakers, I'd like to put up this disclaimer about HIPs that are early in the stage of the life cycle. And this is basically speaking to the fact that there's no confirmed estimated time of arrival or delivery for the deployment of these HIPs on mainnet. And just keep that in mind. So I'm going to keep that on the screen for a little bit, allow you guys to read it, and that's great. So now I'd like to introduce our speakers, our wonderful speakers. First up, we have Jeremy from SEALCOIN, which is it's a decentralized IoT platform and embedded software, and they develop embedded software for IoT devices. And he's the CTO there, so he's going to provide some good insight on this HIP that they've brought forward on post-quantum cryptographic algorithm on Hedera. And of course, we have our own Nadine, who is a developer advocate here with us, who will support that and answer some questions during the Q&A of that. And then after that, we have a sponsored fees HIP, which I'm particularly excited about. It's a neat opportunity for developers and applications dApps to make money using Hedera by setting their own, or I'm thinking about it differently. This is a way for applications to have a solution to where users won't have to care about using HBAR to transact, and the application can have an account to sponsor the fees for them. Greg will speak more on that. And then finally, we'll wrap it up with our own Jake Hall, who is a developer relations engineer. I'm sure a lot of you know him. He's been all over Twitter about AI and AI agents, and he's done a lot of work in that space. He's very knowledgeable, and he'll be joining about 15 minutes or so into this call. And anyway, without further ado, I would like to just invite Jeremy. Would you like to come up and talk about the quantum cryptographic algorithm HIP?
Yeah, sure. Thank you, Michael.
Yeah.
Can you share the screen? Thank you. Yeah. Hi, everyone. My name is Jeremy Pansier, and I'm glad to present a new Hedera Improvement Proposal titled Support for Post-Quantum Cryptographic Algorithm. In this session, I'll walk you through the motivation behind this HIP, the algorithm we're proposing to integrate, and how this benefits the Hedera ecosystem. Okay, so go next, please. Thank you. Why this HIP matters? So, as many of you know, quantum computing is evolving rapidly. While we are not there yet, a powerful enough quantum computer could eventually break current cryptographic standards, including ECDSA and EG 25519, which are currently supported by Hedera. The risk isn't just theoretical. A known attack strategy called harvest now, decrypt later involves bad actors collecting encrypted data today with the expectation of decrypting it in the future using quantum capabilities. While this primarily concerns encryption and decryption, digital signatures are also at risk due to the well-known Shor's algorithm. At the same time, regulators, including NIST and the European Union, are pushing for adoption of quantum-safe cryptography. This HIP is about positioning Hedera ahead of that curve by integrating a post-quantum algorithm. So, yeah, we evaluated several post-quantum cryptographic candidates and selected MLDSA, formerly known as Dilithium 5. It's based on a lattice problem called module learning with errors, which has strong theoretical security against quantum attacks. It has been officially selected by NIST for standardization. So NIST stands for National Institute of Standard and Technology. It's a US government agency that develops and promotes measurement standards. In other words, they identify the most robust algorithms and advocate for their adoption. And we also looked at the practicality of this algorithm. Signature size is about 4.6 kilobytes, which is manageable. It also has solid Java support, notably through the Bouncy Castle cryptography library, which make integration much easier. Among the available post-quantum algorithms, we selected MLDSA 87 for its balance of practicality and security. But we also consider Falcon, Sphinx Plus, and SQI sign. MLDSA is quantum safe, but signature size is larger than classical signatures. Falcon is great in terms of signatures, but it requires floating point arithmetic that is vulnerable to side channel attacks. And it requires a bit more computational power compared to MLDSA. Sphinx Plus is extremely secure, but with signature size reaching 17 kilobytes, it's too heavy for most DLT use cases. SQI Sign offers very compact signatures, but it's still early stage and computationally demanding. So MLDSA struck the best balance, secured, standardized, and practical to implement. So what exactly will MLDSA enable for Hedera? Here are the core capabilities we are proposing to implement. Users will be able to generate new quantum-safe key pairs, sign transactions, and Hedera nodes will be able to verify those signatures. We also extend the Hedera SDKs and APIs to support this, so developers can adopt it without changing the way they interact with the network. One of the key challenges is the size of the signatures. 4.6 kilobytes is significantly larger than ECDSA. To address this, we propose an adaptive fee model. Classical transactions would continue under the current fee model, while transactions using MLDSA would have higher fees. Even though the current fee model already accounts for signatures or transaction size, we would still need to consider potential increases in computational costs. Okay, so with this HIP, we're not replacing existing algorithms. We're adding MLDSA as an additional option. Talking about security, we're improving it against future attacks while staying secure against present threats. There are no breaking changes. Developers and users can continue using ECDSA or ED25519 if they prefer, but for those who want quantum resistance, the option is there. So implementation plan. We have outlined a 4-phase implementation plan. First, will enable key generation, signing, and signature verification. Then we'll add MLGSA support to the Hedera SDKs and API. Then we'll implement the fee model. And finally, we'll monitor performance and optimize based on feedback. Okay, but adoption won't happen unless we empower developers. That's why we'd need to deliver updated documentation and API references, step-by-step tutorials for integration, webinars to explain the importance of post-quantum cryptography, and workshops to walk developers through the integration process. And yeah, for the next steps, to the best of my knowledge, this HIP requires council approval. From there, we'll gather community feedback to refine the proposal before implementation and testing. And then we would think about an adoption strategy to promote post-quantum transactions. And that's it.
Great. Thank you, Jeremy. Yeah, I appreciate that. It's very insightful. If you could, just for our audience, could you talk about a little bit about SEALCOIN and speak a little bit to this HIP and how it will enable SEALCOIN in your embedded IoT devices? What it can do?
Yeah, so SEALCOIN is creating an ecosystem for the IoT devices, and to do that, we are using a token built on top of Hedera. Because of the quantum threats that we are aware of, because we are closely working with cybersecurity companies, we are really attached to improve the security of the devices, and yeah, by improving Hedera, we are also improving the token that we are using for SEALCOIN.
Awesome, thank you. Yeah, I appreciate that answer. I'd like to invite Nadine up if she'd like to speak a little bit to this in support.
Hi, Michael. Yes, please.
How are you doing?
We're good. First, amazing. Let me say how much we appreciate all the effort and all those diverse perspectives on this topic, because post-quantum cryptography is super important for the future. So the earlier we kind of start to kick off those conversations, the better. And even though hopefully or probably we won't face a large-scale quantum threat issue for several years, it's fantastic to see everyone in the community already thinking and planning ahead. So I absolutely love this tip, and please everyone share your feedback on it and tell us what possible standards you would like to see so we can open up this conversation and then in the end implement what is wanted. Now, I just wanted to talk a bit how we discussed about this in Hashgraph. So we've been thinking of other possible standards, and while the lithium is certainly super secure, it has, as Jeremy has mentioned, quite a large signature, so around 4.6 kilobytes. So we were thinking also of something different, which is Falcon, which provides pretty much the same quantum security, but with much smaller signatures, so only 1.3 kilobytes. This could help to preserve Hedera's advantages of having this high throughput and also the low fees we're actually known for. The issue here is that currently Falcon has no standard which is fully accepted by NIST, but we do plan that this will come out pretty soon, probably within the next half year, and we can already develop and test bits and pieces and then maybe switch over when we have the final standard. There was something mentioned about side channel vulnerabilities on the slides, and I think it's also very important to stress there that this is a very valid point, but everyone who's working in the industry and knows cryptography is aware of this, and it can be mitigated with careful coding. So there's a multitude of potential cryptography standards that we can look into. And thus, please, again, if you have one that you think is very much needed for your project, comment on the HIP, reach out, let us know your needs and questions. And yeah, that's it from my side. Thank you so much, guys.
Thank you, Nadine. Thank you so much. We actually have a couple questions here from the audience, so that's great to see. It's kind of a two-part question. The first I can answer, and then maybe you guys can speak a little bit to it to add color. And then the second one I'll give to you guys. The first is, if we could put it on the screen here, is there a timetable for quantum capabilities to be achieved? And now, of course, at the beginning of this call, we put up a disclaimer saying that for these HIPs that are early in their life cycle, we don't have estimated time for this feature to reach mainnet. But that being said, we encourage people to engage in the conversation. Where we have the GitHub link up there for the pull request. Please go there and start engaging. We like to see that. And if anyone would like to add color to that answer, please feel free. And if not, there's a second part to this question that may we put it up on the screen is, does Hedera have an advantage over blockchains to combat the quantum threat? If so, why?
Sure. I mean, to the second question, because we're S&T and Byzantine fault tolerant, so that's definitely a massive plus there. And then when it comes with the implementation, as said, we're currently exploring different possibilities. The HIP that SEALCOIN has mentioned is definitely a great start, and engineering is talking with Lehman, so we're on the ball. Now, there's really no rush because it's a couple of years until this really would be an issue. So instead of implementing something right now, it's actually good that we take the time, see what the fully fledged standards are going to be, and which are hopefully coming out in a couple of months, and then take it from there.
Perfect. Jeremy, anything you'd like to add?
I would have say the same to answer to the first part of the question. Yeah, as Nadine said, there is no threat before a couple of years, even if, with the involvement of AI, maybe it could happen sooner. I think we have some time before being threatened.
Cool. Perfect. All right. I guess that brings us to the conclusion of the quantum HIP. I would like to next up talk about sponsored fees. This is a really very interesting HIP, and our one and only Greg Scullard will be speaking to this. Greg, for those of you who don't know, he's been with us since the launch of Hedera. He's been an incredible advocate for us, and his Twitter handle is Hedera Kid. So I'll let you go ahead and take it away. I don't need to further butcher this introduction. Greg, go ahead and take it away. Thanks.
Thank you, Michael, and hello everyone, and thank you for taking the time to participate in this discussion. Sponsored fees is a HIP that is in progress. If we can move to the next slide, please. I guess in terms of why this HIP matters, one of the things that came to my mind was, if you were ever, as a child, given pocket money, suddenly my parents would usually say, "Don't buy sweets." And guess what I would go and do? I would go and buy some sweets. This is to try and kind of put this HIP into context onto the next slide. Approvals that exist today on Hedera, and most of the networks that have an EVM where you can do approvals through smart contracts. Alice can approve HBAR to Bob, so that Bob can spend it with an exchange, send it to a friend, send it to a smart contract. but Bob cannot use the approval to pay for transaction fees or token custom fees. And one of the challenges for Alice here is that if she approves Bob to, to receive 100 HBAR or to use 100 of her HBAR to spend on smart contracts, for example, she has no way to control or to ensure that that's what Bob will do with those HBARs. Bob may send them to an exchange and cash them out and go and buy some sweets. So with this HIP, we're giving Alice a little bit more control. Next slide. More also importantly, with the current approval solutions, you cannot use them to pay for transaction fees. You can only use them to send in crypto transfers or to send to a contract. So other solutions for Alice to be able to, or for Bob to be able to spend some of Alice's HBAR would be for Bob to create a transaction and designate Alice as the payer for the transaction fees, and then send the transaction to Alice for her to countersign and essentially approve that Bob spends HBAR on her behalf. Or they can use scheduled transactions where either Alice or Bob can send a transaction to the network, and then the other party has to countersign this scheduled transaction so it's executed. But that means that Alice has to always check what Bob is doing with those HBARs that she's allowing him to spend. And, he could sneak in a crafty transaction to buy some sweets, which if Alice doesn't catch it, then, obviously he'd have a bag full of sweets. So, on the next slides, what if there was another way? What if we could increase the scope of approvals to cater, for example, for instances where you would want to grant someone some HBAR, but have some control over how those HBARs can be spent? And this is very much the crux of this particular HIP. So on to the next slide. And they're not super clear. We can see that Alice can grant allowances on the left-hand side to Bob for HBAR tokens and NFTs. With this particular HIP, we're adding scopes to the HBAR allowance. It's not necessarily changing the token allowance or NFT allowances, so that when Alice grants an allowance to Bob, she can say, here's 100 HBAR that you can spend on crypto transfers, but nothing else. Or here's a 50 HBAR you can spend on gas fees and transaction fees, or token custom fees, and which can be either tokens or HBAR. As you know, custom fees on tokens can include payments in tokens like USDC, for example. So the idea with this HIP really is to increase the scope of allowances so that Alice has far more granular control over how those allowances that she's giving away are being given. Allowances can be unlimited or limited in quantity. So I mentioned allowing 100 HBAR, but Alice could just give unlimited access to her wallet to Bob for transaction fees, for example. And of course, she's able to revoke those at any time if Bob is spending too much. We'll also be looking at enabling the management of allowances via smart contracts so that a contract can allow or approve spending for another account. And there will be changes, of course, to Mironode queries so that the query response indicates the scope for approvals. On to the next slides. So from a security and backwards compatibility point of view, as I said, Alice can revoke allowances at any time. So even though we're adding those scopes, Alice still retains full control over the allowances, and any allowances that have existed prior to the HIP being deployed will default to what they are today, which is crypto transfer. So their purpose will be unaffected by the change. If a scope isn't specified, it will default to crypto transfer, which is the current behavior. So no major backwards compatibility concerns. So in conclusion, the HIP opens up a bunch of additional use cases with those additional controls. For example, and I think that's what Michael was alluding to in the introduction, a gaming company can approve HBAR to their players who no longer have to acquire HBAR to play the game. And this is a, no pun intended, game changer for onboarding new users who are not necessarily familiar or wanting to interact with an exchange to acquire cryptocurrency. But a gaming company in this case retains full control over their own HBAR, and they can entirely control or choose how to make those available to their users. It could be even given or done on a temporary basis. Here's a a coupon in a way for playing the game for up to 100 or 1,000 HBAR, and when you're done, then you have to go and purchase your own. Foundations and investors are also very interested in this. They can grant projects and be sure that the granted amounts are used for the appropriate purpose. If I grant some HBAR to a project, and there is a tacit understanding or contractual understanding that this is for transaction fees, but the project does a rug pull on me as a foundation and sends them to an exchange to buy some sweets, then I'm in a lot of pain to try and recover those funds legally or otherwise. So in an event that a project doesn't deliver, the foundations or investors are able to keep control over their HBAR. We also have potential use cases where an intermediary can hold HBAR on behalf of an enterprise who doesn't want to hold cryptocurrency on their books, and the intermediaries can charge the enterprise a monthly fee for the service in fiat. And again, this is a good step forward for adoption. So the HIP 1068 is in draft. We welcome your comments before it is submitted to HIRO and the Council for approval and implementation. However, I should say that there is a competing HIP which looks to implement something that we call, or the HIP refers to as hooks or Lambda functions that you could attach to your account. And then those functions could be set up to essentially manage approvals. So it's a far more, I would say, flexible, far more programmable way of implementing something similar to this delegation or approval of funds. So we're considering whether this new HIP is essentially a suitable replacement for 1068 that I just discussed today. So inviting you to comment, contribute as per the other HIPs, and to look at this other one on the hooks as well. Yeah, we want you to tell us what you think. Thank you very much.
Thanks, Greg. Just one thing that I wanted to ask. I didn't see this in the comments, but and maybe it's probably not possible, but we get a lot of questions about people who are developing dApps where their users don't want to care, not just about not having HBAR, but not even having a wallet. Is there a way that dApps could integrate some sort of mechanism where the users wouldn't even have to care about a wallet? They could just click an approve button, and then they can complete the transaction, whatever they wanted to do with whatever application it is.
Yeah, I mean, today your dApp could be completely walletless, generate transactions, send them to a backend which would sign them and execute them. But I think the notion of a dApp or Web3 is that you are custodians of your assets, right? If it's NFTs in a game or something like that, they belong to you. Otherwise, you're more into something that's more akin to Web2, where you never own anything because it's all being done by accounts that are controlled by someone else. So I think this HIP is very much more in the sense that a wallet could be created for you. But you don't have to, and you would have to approve transactions potentially. You could see things appear in your wallet in terms of NFTs and so on and so forth. But and this could be a great way for people to get to learn and to understand what decentralization and self-sovereignty of assets means in the context of Web3, but without having to learn and understand how to purchase HBAR. And I think that's a big hurdle for most people. Most people I speak to in my social life who know nothing about cryptocurrencies, they've not necessarily bought shares on the stock exchange, and that's essentially what we're asking them to do. Register with the central exchange, transfer some funds, get some cryptocurrency, and this is like, whoa, hold on, I can't be bothered. Sign me up to Xbox Live. So yeah, potentially this HIP or the other one on hooks could certainly help to smooth the path to adoption.
Mass adoption. Awesome. Yeah, great. Thank you so much for that presentation. That is a very exciting HIP. And just like Greg said, please, here's the link on the screen. If you could go to that and contribute to the conversation, we love to see that. It helps us to gauge the engagement, and also is we consider it in our roadmap. So please contribute to those discussions. Okay, next up, we have Jake Hall, who many of you know. He's in the AI space. He's developed a lot of tools around AI. I don't need to give much of an introduction. You guys know him. He's up and coming. Let's hear it for Jake. No, you're on mute, Jake. Just come off mute.
Test, mic test.
Yeah, there you are.
Sorry, guys. Yeah, no, I just had to. I saw my Hedera hat, so I thought I had to put it on. I should have had it on before. But yeah, no, thanks for having me on. I've got lots to talk about today.
Thanks for joining.
Should we get straight into it? Should we
Yeah,
talk AI?
Yeah, let's do it.
Cool. Well, in that case, I'm going to share my screen then. I was trying this earlier. The setup's a bit dodgy. Let me give it a go now. So I'll go first, share my screen, and there we go. And now I'm hoping if I click play, I can't now see the screen, but can you see this presentation? Yeah. AI on Hedera. Okay, wicked. So right, today I'm going to be talking about basically everything AI on Hedera. Now, not quite everything. We're still missing out a really big chunk of Hedera's involvement in AI, and that's going to be the stuff which people like Prove AI, Prove Labs, Prove AI and Equity Labs are doing on the data integrity side. I'm focusing more so on what you can do as a normal developer on Hedera. How can you use AI to develop on Hedera? I'm going to showcase some of the tools that we have. But also, if you're interested in AI agents, what you can do with AI agents on Hedera. And there's a lot to speak about here. I think I've only got about 20 minutes in this slot, and I spent 1 minute of it not talking because my mic wasn't plugged in. So I'm going to try and get through into it. But definitely at the end, if you've got questions, please ask. I'll also be monitoring the comments. Now, we'll break it down into two parts, using AI to develop on Hedera, and we're going to show some of the tools that you can use in order to do that, as well as AI agents. What are the different AI agent frameworks we have? What are the toolkits? What are the different protocols? And what are the different the recent improvements that we've made to the actual Hedera consensus layer, which will be really suitable for AI agents? And then finally, I'm going to give a quick plug to our AI agent hackathon, which is starting in a couple of weeks. So definitely, hopefully, these can sort of give you a few ideas as to maybe what you can do if you enter it, or just the awareness that is happening. So let's start off with developing, using AI to develop on Hedera. Now, we've got these custom GPTs. Obviously, you can use generative AI as you wish, as you probably are doing so if you're a developer. If you're not, I'd recommend you do it because it's going to speed up definitely some of the more simple tasks. But actually, if you've got ChatGPT, you can go over to the custom GPTs and you can search for Hedera Hivemind. And I quickly prompted Hedera Hivemind just before this. I asked it, what knowledge does it know? It knows pretty much everything that's in our docs, and it's got a lot of the most important repos. So for example, general Hedera knowledge, it's got all of the documentation in its backend, in its vector database. Smart contracts as well. It's got loads of smart contracts from the smart contracts repo. It knows about all of the latest HIPs. Local node setup, if you're looking to start running your own node when it comes to testing, often you'll find it's much quicker. I definitely recommend it. You can use Hedera Hivemind to help you start on that journey. Solo as well, if you don't know what Solo is kind of similar to Hedera local node, but it's like a more robust version where you literally have your own Hedera node from the Hyro source code. You have your own Hyro node running on your local machine. You can also use Hedera Hivemind to do that. And then of course, SDK usage, the stuff which is the bread and butter. So if you are looking for something which is domain specific, you're more likely to get less hallucinations if you use Hedera Hivemind. Definitely recommend that. If you're not a ChatGPT guy, you can also use Ask an AI on our Hedera Discord. So I think maybe we can plug the Discord up here now. It's hedera.com/Discord. That will take you to it if you're not in it already. But essentially, there's a channel on here which is linked up with Kapa. Kapa is another AI vendor which we use. And similarly to the Hedera Hivemind on ChatGPT, it's got all of the access to the latest documentation. You can query it on here and you can ask on here. So that's just a bit of background as to some of the tools that you can be using as a developer. Obviously, keep it in with your existing generative AI, ChatGPT, LLM workflows, but just letting you guys know that there's something which is very specific to Hedera. If you want to do something which is domain specific and there's a risk of hallucination, these are probably the tools which you want to be heading over to. As well as, of course, the team. I'm always here to help, as are most people on these calls. I know Michael will be happy to assist too. Cool. Let's now go over to AI agent stuff. Now, the first thing which I want to just give a quick overview about is the Hedera AgentKit. Now, the way that you can think about this Hedera AgentKit, it's an open source repo. You can contribute to it. It's an open source repo which essentially acts as the mastermind, as the go-to library if you want to integrate Hedera into an existing AI agent framework or an existing custom-made LLM flow. The Hedera AgentKit is really the kit which you want to be using. And I'm going to go into that in a bit more detail in the following slides. But just while we're talking about the Hedera AgentKit, what can you do? And I want to make these slides as actionable as possible, just so that it's not just listening and consuming stuff, so that we can actually know what exactly we can do as developers, as community members, to help contribute to Hedera and help build out the use cases on our network. So the first thing which you can do is you can have a look at the open source repo. I've shared this link, so hopefully we can get it up, or we can communicate it after this. But this you can find on our GitHub. It's totally open source. Have a look at it. Clone it, but also raise some pull requests. And this is something which we're really looking to do. Currently, it covers the basic Hedera functionality, things like creating tokens, transferring tokens, checking balances, a few mirror node queries. But actually, to extend it out further, we can do things like adding in decentralized exchange swaps, or adding in the ability to stake and unstake. And other sort of protocol integrations. If you're listening from the community here, you've got your own protocol, please reach out and we can talk about how can we integrate your specific functionality into our agent kit so that it helps in what I'm about to discuss, which is first and foremost our LangChain or LangGraph tools. And what this is it's a tool which is compatible with the LangChain LangGraph AI agent framework, which allows you to build AI agents using LangChain. This, again, all of it's open source. You can play this out yourself. Similarly to before, I've sent the repo so we can communicate this out. But what I recommend here is clone the repo, test it out. There's a script which you can just run with npm test. That pops up with a CLI chatbot that you can use to start creating tokens just via a CLI text input. So install it, implement it into your dApps. The benefit with LangChain versus what I'm going to describe next is that LangChain is very extensible and it's very customizable. You can really create these custom AI agent flows or implement it into your existing Web 2, Web 3 application with very little developer friction. But also you can integrate it with other agentic tools. So it's not just Hedera, which has compatible tools of LangChain. There are many other tools. You can do tools like searching the web, generating photos, all sorts of stuff. You can create your own custom tools as we've done with Hedera. The other thing which I want to show is another very popular AI agent framework, which has a different set of benefits and value propositions when compared to LangChain and LangGraph. So that's, of course, the Eliza plugin. Now, we have a Hedera Eliza plugin, meaning you can use the Eliza agent operating system to actually interact with Hedera. And where Eliza is really strong is when it comes to these sort of personalized autonomous agents. It's not quite so easy to integrate Eliza, let's say, into your existing web application with some specific functionality. But what Eliza is really great at is you can create your own persona, your own character in the character file, and you can hook it up to X, you can hook it up to Discord, to Telegram, whatever you wish, and you can have this really you can almost have a person. It basically creates a person who has these actions to tools. They can swap on behalf of other people. They can create tokens for people. That's where Eliza becomes really good. We have a Hedera Eliza plugin. Again, I've shared out the link. Hopefully we can get this communicated ASAP. But what can you do with Eliza? What can you as developers action from this particular session? Well, the first thing you can do is you can spin it up on our Gitpod environment. Because Eliza is an operating system for AI agents, it's not as easy to set up as, say, the LangGraph agent. So we've got a Gitpod ready for you to start testing with, and you can spin up that Gitpod environment totally free. You just need to create an account, and you can use that to start interacting with Eliza and interacting with the Hedera Eliza plugin. The other thing you can do, you can create your own personalized character file. I mentioned this earlier. This is how you give an agent particular characteristics. And interestingly, what the Eliza team have done here is quite innovative, is they use this concept of entropy with LLMs and sort of, yeah, the way that large language models work. And so that the AI agents don't just become this really monotonous, one-sided being or entity, it will randomly pick particular aspects from your character file, so that in one message it uses that particular trait, in another message it uses that particular trait. It can interact with people on X, it can reply to people, it can like stuff, it can share stuff, but every time it's slightly random based on what you've set. So every time you get a different flavor, and it's more human, I suppose. But yeah, you can also connect it with X, Telegram, Discord. There's other bits and bobs where you can connect it to. Right, that's it for the AI agent frameworks, but we're not done with AI agents. And the next thing which I want to share is a HIP which has been in the works, and that is HIP 991. What is this HIP? This HIP allows for a consensus topic. The consensus service, if you don't know, is it's like a pub sub message bus, totally decentralized on Hedera, where you can create a topic and you can submit messages to it. Now, currently, those messages cost about 1,000th of a cent, something to that effect, maybe 100th or it might be 100th of a cent. 100th, got it, okay. So, what? Yeah, 100th of a cent, which is really cheap. And for that reason, Hedera is the network which has the most amount of transactions of any single network. For that reason, we had sort of 7,000, 8,000, 9,000 TPS running in the past. But this new HIP actually allows you to create a custom fee on a consensus topic, similar to what we already have with NFTs and with fungible tokens. You can now have a custom fee on a consensus topic, meaning, yes, you pay that 0.0000 whatever 1 cent fee, but also you have to pay this custom fee of $5, $10, one meme coin particular token. And only once you've paid that is the message sent. Where this is interesting for agents is you can have an AI agent which consumes this particular topic. It's subscribing to it. And it will know if I've got this message, someone's paid $10, someone's paid 500 JCoolCoin, which doesn't exist. So you can actually use this to create a verifiable proof of payment, which then initiates an AI agent to use their compute and react with it. What can you do with this? First thing you can do is you can check out the new HIP. You can get involved with Hyro. Hyro, obviously, that's the open source governing council, essentially, of Hedera, of the source code, working with the Linux Decentralized Foundation Trust. But you can look at the HIP, you can read it, you can play around with the latest SDK. This is currently on testnet. Not sure if it's on mainnet quite yet. And I know there are sort of some potential delays with it, but currently you can play around with it on testnet for sure. I'm going to be releasing a tutorial out on this, so definitely check that out. And then also have a think about what you can build with it, because again, we have this Hedera AI Agent Hackathon coming up over the corner. So now's a good time to start bouncing ideas, ideating stuff that you can do. The other thing which I want to share is a protocol called HCS10. HCS10 is also built on top of the consensus service, and it's a protocol which has been developed by a really amazing contributor to our ecosystem, Hashgraph Online. Hashgraph Online, that if you don't know, they are a DAO which is governed by some of the leading community, some of the leading protocols and wallets and ecosystems in Hedera, the likes of Hashpack, Kabila, Centex, NFT. And they've established a really robust set of protocols which live on top of the consensus service that allow this unbelievable usage of it to extract value from the consensus service that is not typical from your typical pub sub service. And one of these protocols and standards which they've created is HCS10. This is an AI agent to AI agent communication platform. It allows AI agents to message each other in a totally decentralized way without needing any sort of third-party API. They use the Hedera consensus service to create a particular topic which only those two agents can communicate on, and they can send messages back and forth, they can trade, they can plug it into the previous HIP 991 to even start paying each other in a way where it's verifiably proven, and the AI agent action is only taken after that message has been received. So this is really exciting. It's going to be a really big focus to the AI Agent Hackathon, which we're running. We've got a stream specific for this. So I think if you head over to hashgraphonline.com/hackathon, you'll be able to sign up. Definitely recommend you do it. So do that, but also have a look at the HCS10 standard, have a look at the documentation, hashgraphonline.com. Have a look at the standards SDK. This provides a really easy interface to start interacting with this particular standard. And again, brainstorm ideas for our AI Agent Hackathon. So we're calling all AI agents, all of their humans, build your product. If it's on a different chain, come over to Hedera, give it a try. If you're on Hedera and you're interested in AI agents, this is the perfect opportunity to have a play and hopefully win some cash prizes. There's $30,000 on the line. But I just want to have a quick question to sort of leave everyone on, which is, how can we use HIP 991 and HCS10 to create genuinely revolutionary Web3 and AI use cases on Hedera? These two protocols or sort of native functionalities on the network are truly unique. There's not another network that I'm familiar with, layer one chain, who has these functionalities out of the box, which leverage the native service. So I want to leave the question here again. I'm going to repeat it one more time. How can we use HIP 991, the ability to pay a fee and provably demonstrate that value has been transferred when receiving a message for an AI agent, coupled with HCS10, the ability for AI agents to communicate with each other? How can we use those two features to create some disruptive use cases that haven't been seen before? And of course, the Hedera Hackathon starting on the 11th of April, something around then, that will be the best place to put it to the test. So really recommend you sign up. Again, I'm always here to bounce ideas off. Really keen to hear some of the insights from the community members. And as well as all of the team at Hashgraph and all of the team at Hashgraph Online, everyone's really willing to help. I know there's actually a call going on, I think it might be now, where they're doing it. But there's going to be lots more announcements coming out. So stay tuned and sign up already if you want. Michael, that's it from me. I'm not sure.
That's great.
Time, but
that's right on time. Yeah. Cool. Thank you so much. Perfect presentation. Absolutely brilliant. Yeah. So now we'll have 10 minutes of QA for all of our presenters. And before we talk about this QA, I wanted to talk about that we created 2 new Discord channels. One is for a feature request desk, and another one is for another desk, HIP's discussion desk. So they're meant to centralize feedback. You can give us bug reports, offer HIP discussions and ideas to improve engagement. We're always keen on listening to that and just keen on listening to the feedback and hearing from you guys. We love that. So in next call, Simi will share more details. And that call is slated for April 24th. So now enough of me. Let's hear from our presenters and any QA that might be coming up as from a result of this presentation. I know there was one question that we had. Let's see if we can put it on the screen here. It was related to the quantum HIP. First off, yes. Yeah, is there any initial information to share about quantum resistant chips from CLSQ being used in the network infrastructure? Anything you guys can give, Jeremy?
Yeah, okay, so yeah, CLSQ plan to release the QS 7001 by the end of the year, and this chip is already integrated MLGSA 87. So that would be the best choice for IoT devices that want to transact using a token on Hedera. If Hedera integrates also the MLGSA 87. So yeah.
What else we have? Can we put up the next question? Greg, you want to take this one?
Yeah, happy to. I don't know if it's true. Maybe not. Yeah. If it's a rumor, it's not one I'm aware of. Is all I can say.
What is Hedera utilizing to achieve maximum computational power for scaling AI? Thanks. Jake, you want to talk to that one?
So what is Hedera utilizing to achieve maximum computational power for scaling AI? So there's Hedera, the native Hedera service. We're not an AI company. Hedera is it writes code for, it provides infrastructure for distributed ledger technology. So we're not necessarily going into the realms of, okay, let's use GPUs and invest loads of money in GPUs and building these data centers and gigafactories and whatever. Where we do sit into that equation is AI, people who are developing AI models or people who want to leverage artificial intelligence within the context of Web3. They can, of course, use our distributed ledger to provide transparency, to provide immutability, to provide the ability for agents to transfer value. So I wouldn't think of it as that being necessarily Hedera's job. That's probably something which Microsoft, OpenAI, Google are thinking more about. We're focusing more on, okay, how can we make the distributed ledger as cheap, quick, sustainable, and easy for developers to build on as possible. And that will, of course, enable use cases within the AI sector, but it will also enable use cases within DeFi, within real-world asset tokenization, something which I know many people on this panel can speak to in a lot of detail. But in terms of, what is Hedera utilizing to achieve maximum? we're not probably utilizing too much. We're focusing more on making sure that our nodes can run the Hedera or Hiro consensus algorithm, and making sure that we're delivering on our roadmap, make sure that we can get other people starting to build. That's what we're focusing on.
Thanks, Drake. Great answer. Yeah, we're not an AI company, but we do stuff in AI. There's another question that's come up that's interesting. The USA administration has promised a $500 billion investment to AI. Is Hedera partnering in the USA investment? In this USA investment? I have no idea. I don't have any information regarding that. I do know there's been a $500 billion investment into AI, but I don't know if Hedera is partnering with the USA in this $500 billion investment. Does anyone?
I guess to Jake's point, we're not an AI company, right? So maybe some of that investment will trickle down into use cases on Hedera, and that's certainly something that we're trying to promote, and through the work that Jake is doing with the community, trying something that we want AI-driven use cases on Hedera for sure. But we're not an AI company first. So my guess, without knowing for sure, is that investment would go into AI companies first.
Perfect. Cool. And this next question I can answer.
On the digital euro question.
Yeah.
Even if there is or there was such a project going, it wouldn't be for us to announce before it is announced by whoever is issuing the token. That's a mantra that we live by at Hedera. We don't announce projects on behalf of projects. We let them go public when they're ready. So even if I knew about such a project, I wouldn't be able to say.
Yeah. Great answer. Thank you. Thank you, Greg. Okay, this next question by Lewis. These are new HIPs that are being developed by Hedera. Well, they're actually being developed by quite a few members, but will they be integrated with Hiro? So if I could just speak on this, I'd like to say that several months ago, earlier in 2024, there was a move that happened with Hedera that we donated our source code to the Linux Foundation, and they made an org in GitHub called Hiro Ledger, and we donated all our source code. And over the past, since that happened, we've been migrating our repositories over there. And just yesterday, the HIPS repository also migrated. So every single HIP, first of all, they're no longer called Hedera Improvement Proposals. They're Hiro Improvement Proposals. So these HIPs are now necessarily going through the Hiro Ledger org, and they'll be in that code base. Hedera will choose whether or not they want to adopt the HIP on mainnet if it's a HIP that touches the source code. So yes, they will be integrated with Hiro because they are now in the Hiro code base, and not. Yeah.
Michael, is it fair to say that, I mean, the question would be phrased the other way around? It would be, are the HIPs on Hiro, which are being developed by Hashgraph predominantly, but also other open source contributors, are the HIPs on Hiro being integrated to Hedera, which is the public instance of Hiro?
Yes. Yeah. Consider it that Hedera is like the first iteration of a Hiro ledger that's a now public ledger, and it's always been a public ledger, but Hedera Council chooses when those HIPs go through and are put into the Hiro ledger code base. They can choose whether or not they can, we will put that feature on Hedera mainnet. So it's always going to rest in the Hiro ledger code base. And then Hedera will have discretion over whether or not they want to enable that feature. Hopefully that brought some clarity to that question.
Yeah, maybe just one comment, Michael. You said Hedera approves HIPs in Hiro, I think, which is slightly incorrect. The Hiro has a technical steering committee, which includes community members and people from the Hedera team and Hashgraph team. they are the ones who approve changes to the higher code base. And then Hedera optionally can choose not to include a particular change into the code that runs on mainnet.
Right. And to be totally technical, the Hyro TSC accepts the HIPs. They can accept or reject the HIP after last call. And then Hedera can choose to approve it or not approve it on Hedera mainnet.
Correct.
All right, great. It looks like we're at the top of the hour. We're 1 minute over. This was a wonderful call. I love it. Thank you all for joining. Thank you for your time. Thank you guys for watching. I hope you guys are excited for these HIPs, and I'll see you guys with Simi on the next community call that we have. So thank you so much.